So continuing with our lesson on...
Fantastic job getting this far. Let's learn about summarizing data with aggregate functions. When analyzing data, we often want to understand the dataset as a whole, in addition to looking at individual records. One way to do this is to summarize the data using SQL's aggregate functions. An aggregate function performs a calculation on several values and returns a single value. We already know one aggregate function, count. We'll now learn 4 new aggregate functions, allowing us to find the average, sum, minimum, and maximum of a specified field. Let's look at some examples of how they work. These aggregate functions come after select, exactly like count. This first query gives us the average value from the budget field of the films table. That's an average of over 39 million per film in the films table. The sum function returns the result of adding the values in the budget field. Here, the total budget of all the films is over 181 billion. The min function returns the lowest budget, and the max function returns the highest budget. The 2006 South Korean movie, The Host, had a budget of over 12 billion. That sounds huge, but our data is in multiple currencies, so a true comparison would require currency exchange rates as well. Note that we operate on the field or column with all of these aggregate functions, not the records or rows. Although these functions appear to be mathematical, we can use several of them with both numerical and non-numerical fields. Average and sum are the 2 aggregate functions we can only use on numerical fields since they require arithmetic. We can use count, minimum, and maximum with non-numerical fields, as we already saw with count in previous lessons. Count can provide a total of any non-missing or not null records in a field regardless of their type. Similarly, minimum and maximum will give the record that is figuratively the lowest or highest. Lowest can mean the letter A when dealing with strings, or the earliest date when dealing with dates. And of course, with numbers, it is the highest or the lowest number. Here are some examples of using these functions with non-numerical fields. We can select the minimum and maximum country from the films database and see that our minimum country, or country that would come first in the alphabet, is Afghanistan. In contrast, West Germany is the maximum country that would come last in the alphabet. Our database does not contain any films made in Zambia or Zimbabwe, but it does have at least one film made back when Germany was 2 different countries. Notice how all query results have automatically updated the field name to the function, in this case, min. It's best practice to use an alias when summarizing data, so that our results are clear to anyone reading our code. That's it. Let's get on to practice.
So aggregate functions and data types. We're halfway through this course and I intend to finish this today. So we've taken up, so far we've taken up the selection of data, then filtering records, and now we're on aggregate functions, to be followed by the sorting and grouping. So for the instructions, aggregate functions are another valuable tool for the SQL programmer. They are used extensively across businesses to calculate important metrics, such as the average cost of making a film. Okay. So let's continue. So the 5 different aggregate functions are average, sum, minimum, maximum, and count. Then we have to test our knowledge of what data types they are compatible with. So for the instructions, it states here that we have to classify the function based on what type it is compatible with. Minimum, it says there minimum can be used on various data types, whereas average can only be used on numerical data, and the maximum can also be used on various data types, the sum for numerical data only, the count can be also used for various data types. Yes, okay, congratulations. We've got aggregate functions under control, okay? So to continue, create the sum of film durations. We have to practice with aggregate functions. Now let's try extracting summary information from a table using these new aggregate functions. Summarizing is helpful in real life when extracting top-line details from our dataset. Perhaps we'd like to know how old the oldest film in the films table is. What is the most expensive film, or how many films have we listed? So let's check again the structure or the columns and the columns or fields of the films table. So to get insights about the films table, here are the instructions. It says here that uses some function to calculate the total duration of all films and alias with total duration. So use the sum function to calculate the total duration. You have to run the code and submit the answer. It says here that uses some function to calculate the total duration of all films and alias with total duration. Then calculate the average duration of all films and alias with average duration. So we have to select average duration as average duration from films. Then find the latest year, release year. Find the latest release year. We have to find the most recent. Okay, most recent should be the maximum. So find the most recent release year in the films table, aliasing as latest year. You have to run the code and submit the answer. Then find the duration of the shortest film and use the alias as shortest film. Duration. Duration. It's the duration. So it's still new, but we have the duration. Okay, you have to check the spelling. Shortest film. Okay. So well done. Then afterwards.
Well done! Now we will combine our filtering skills with our new summarizing skills. We can combine aggregate functions with the where clause to gain further insights from our data. That's because the where clause executes before the select statement. For example, To get the average budget of movies made in 2010 or later, we would select the average of the budget field from the films table, where the release year is greater than or equal to 2010. Here are a few more examples using the other functions. We find the total budget of movies made in 2010 using the sum function. That's over 8.9 billion. Next, we get the smallest budget using the min function, which is 65,000. Here, we query the highest budget using the max function. 600 million feels like a lot again for a movie budget, but this is in Indian rupees for the movie Kites. Finally, we query the count of the number of budgets using the count function, which gives us the total number of non-missing values in the budget field, meaning there are 194 budgets recorded for the year 2010 in the films table. Now that we are doing all sorts of things with our numerical values, we'll likely want to clean up some of the crazy decimals that might appear. In SQL, we can use round to round our number to a specified decimal. There are two parameters for round: the number we want to round and the decimal place we want to round to. Here we have recalculated the same average budget as before, but this time we have included round and specified we want to round to 2 decimal places because we are dealing with currency. The second parameter in our round function is optional, so we can leave it out if we want to round to a whole number. We would get the same result if we passed 0 as the second argument, as it is the default when no number is given. Here is a tricky one. We could also pass a negative number as the second parameter and still get a result. Here, the function is rounding to the left of the decimal point instead of the right. Using -5 as the decimal place parameter will cause the function to round to the 100,000, or 5 places to the left. Round can only be used with numerical fields. Let's practice.
So now we're on combining aggregate functions with where. When combining aggregate functions with where, we get a powerful tool that allows us to get more granular with our insights. For example, to get the total budget of movies made from the year 2010 onwards. Okay. For example, to get the total number of movies made from the year 2010 onwards. Then this combination is useful when we only want to summarize a subset of our data. In our film industry role, as an example, we may like to summarize each certification category to compare how they each perform, or if one certification has an average budget than the other. So let's see what insights can we gain about the financials in the dataset. So use sum for the instructions. Use sum to calculate the total gross for all films made in the year 2000 or later, and use the alias total gross. So we have to Hmm? Use sum to calculate the total gross. Select sum gross as total gross. Or later. So, or later. So, it should be greater than or equal. Then calculate the average amount gross by all films whose titles start with letter A and alias with average gross A. Select average amount. As average gross A. Okay. Title. Antok na. Then calculate the lowest gross film in 1994 and use alias lowest gross. Calculate the highest gross film between 2000 and 2012 inclusive and use the alias highest gross. The highest should be the maximum. Okay, nice. Provides us with several building blocks that we can combine in all kinds of ways. Hence, that's why it's called a structured query language. So now using round. So aggregate functions work great with numerical values. However, these results can sometimes get unwieldy when dealing with long decimal values. So luckily, SQL provides with a round function to tame these long decimals. If asked to give the average budget of your films, 10 decimal places is not necessary. Instead, we can round to 2 decimal places to create results that make more sense for currency. Now we can try. For the instructions, calculate average Facebook likes to 1 decimal place and assign to the alias average Facebook likes. Again, we have to check on the spelling. Okay, well done. Then round with negative parameter. Round with the negative parameter. So the useful the useful thing you can do with round is have a negative number as the decimal place parameter. This can come in handy if your manager only needs to know the average number of Facebook likes to the hundreds, since granularity below 100 likes won't impact decision making. Okay. So social media plays a significant role in determining success. If a movie trailer is posted and barely gets any likes, the movie itself may not be successful. However, remember how the 2020 Sonic the Hedgehog movie got a revamp after the public saw the trailer. So let's apply these to other parts of the dataset and see what the benchmark is for movie budgets. So in the future, it's clear whether the film is above or below budget. So calculate average budget from the films table, alias as average budget, thousands, and round to the nearest thousand. Tens, hundreds, thousands of 3. Negative 3. Okay. Round of applause. The run function is very handy when making financial calculations to get a top level view or specify the penny or cent. Okay. So
Welcome back. In this lesson, we will learn about using more arithmetic in our queries and take a closer look at aliasing with as. We can perform basic arithmetic with symbols like plus, minus, multiply, and divide. Using parentheses with arithmetic indicates to the processor when the calculation needs to execute. Here are some basic examples of how we can use arithmetic in SQL. We can add, subtract, multiply, and divide as follows. In these examples, the parentheses are not required as only one calculation takes place. However, they provide more clarity to the code. But the division gives a result of 1. Why is that? Similar to other programming languages, SQL assumes that we want to get an integer back if we divide an integer by an integer. So be careful. When dividing, we can add decimal places to our numbers if we want more precision. For example, select 4.0 divided by 3.0 gives us the result we would expect, 1.3 repeating. What's the difference between using aggregate functions and arithmetic? The key difference is that aggregate functions, like sum, perform their operations on the fields vertically, while arithmetic adds up the records horizontally. Before we move on, let's run through an arithmetic example using our database. Here we have selected the gross, how much the movie made, minus the budget, how much the movie cost, from our films table. The result is the amount of profit. Notice that the query's result doesn't give us a defined field name. We will always need to use an alias when summarizing data with aggregate functions and arithmetic. As we progress and learn how to manipulate our data, it will be even more important to keep our field names clear. For example, if we're using multiple max functions in one query, we'll have two fields named max, which isn't very useful. This is a situation when it's especially important to alias like we do here. Let's explore how using an alias fits into the SQL execution order. Here is a reminder of the order of execution we know so far. SQL will process the from statement first, followed by the where clause, then the select statement, and finally limit. When adding an alias for a field name in the select clause, we might assume we could use it later on in our query with the where clause. Unfortunately, that is not possible, as we can see by the order of execution.
From the source. Where is the condition? And select. To return. Values to return. And limit is so
We could use it later on in our query with the where clause. Unfortunately, that is not possible, as we can see by the order of execution. The query would not have created the alias yet, and our code would generate an error. Time for more practice.
So it says here that SQL arithmetic comes in handy when our table is missing a metric we want to review. Suppose we have some data on movie ticket sales, but the table only had fields for ticket price and discount. Ticket price and discount. In that case, you could combine these by subtracting the discount from the ticket price to get the amount the film goer paid. Okay, so we have to get the total of the ticket price less the discount to get the net sales. Okay, so we have seen that SQL can act strangely when dividing integers. What is the result if you divide a discount of $2 by the paid price of $10 to get the discount percentage? Hmm? So 2 divided by 20%. Point 2. Okay, you get 0. And so it says that point is technically correct, but it won't be what we will see in SQL because uh, the discount here is 2, then we have to divide it by the paid price of $10. And in if we divide an integer by an integer, it will return also an integer. So since the answer should be the point 2 or hi, hello, thank you so much. Hi, hello. You're all here. Thank you so much. I wish I could poke you. If I could, and I would. I'll go wherever you will go. Thank you so much. Then the answer should be 0. Okay, so SQL here thinks we want the answer to be an integer since we are dividing two integers. 0 is the closest to 0.2. Okay, so aliasing with functions. Aliasing can be a lifesaver, especially as we start to do more complex SQL queries with multiple criteria. Aliases help us to keep our code clean and readable. For example, if we want to find the maximum value of several fields without aliasing, we'll end up with the result with several columns called max and no idea which is which. So we can fix this with aliasing. And now it's over to us to clean up the following queries. So for the instructions, select the title and duration in hours for all films and alias as duration hours. So title and duration in hours. Duration. But first we have to convert this as, since the duration is in minutes, we have to convert this to convert the duration into hour. So duration divided by 60. Since the current durations are in minutes, we'll need to divide the duration by 60. Specified here pala in the instruction. So we have to run the code and submit the answer. Then calculate the percentage. Thank you so much. Hello, Sandboy. Thank you. Thank you, Sandboy. Good evening, thank you. Okay, so for the next instruction, select the percentage of people who are no longer alive and alias the result as percentage dead. So I think it's from the people table. Okay, it says you're from the people table. So let's see the structure of the people table. It says we have to get the percentage of people who are no longer alive and alias the result as percentage dead. So I think to get that we have to where that date is not null. Select times 100 divided by, I think it's divided by count asterisk. Count that date is not null times 100 divided by count asterisk as percentage that. Hmm? 100%. count that date, count that date by 100. Ano na? Count divided by 100 divided by count asterisk and divide by. I specify that it's not null. Then find the number of decades in the films table. Films table. Here is the films table. How do we find the number of decades? Find how many decades the films table covers by using minimum and maximum and alias as number of decades. Okay, so maybe it's based on the release year. So maximum release year minus minimum release year Okay, so it's just arithmetic. Okay, so aggregate functions and aliasing. Now we know that our films table covers films released over 10 decades, and 10 decades are equivalent to 100 years. Okay, so to continue, rounding results. I think this chapter is will be finished in time with this chapter. Then hoping that I could finish this in an hour. Nobody but you. I want nobody but you. Whatever you want, whatever you need, I want nobody. Okay, so we found some valuable insights in the previous exercise, but many of the results were inconveniently long. We forgot round, so we won't make you redo them all. However, we'll update the worst offender in this exercise. So for the instructions, update the query by adding round around the circulation and round to 2 decimal places. Round around the calculation circulation. Okay, duration. So you have to round the duration to decimal places. Okay, that's better. Now you can directly, you can clearly see how long a movie is. Okay. Oh, we finished again. So we've taken it for just an hour. We've been,
Congratulations on making it this far. We'll now learn how to sort and group results to gain further insight. Sorting results means we want to put our data in a specific order. It's another way to make our data easier to understand by quickly seeing it in a sequence. Let's say we wanted to extract our 3 longest coats. If our closet were messy, it would take a long time to find. However, if we sorted our closet by garment type and length, we could quickly grab them. In SQL, the order by keyword is used to sort results of one or more fields. When used on its own, it is written after the from statement, as shown here. Order by will sort in ascending order by default. This can mean from smallest to biggest or from A to Z. In this case, we have one query sorting the budget from smallest to biggest, and a second query sorting the titles alphabetically. Our database contains film titles that start with symbols and numbers. These come before the letter A. We could also add the ASC keyword to our query to clarify that we are sorting in ascending order. The results are the same, and our code is more readable. We can use the DESC keyword to sort on the results in descending order. This query gives us the film titles sorted by budget from biggest to smallest. However, our data contains a lot of null values. We can add a where clause before order by to filter the budget field for only non-null values and improve our results. Notice that we don't have to select the field we are sorting on. For example, here is a query where we sort by release year and only look at the title. However, it is a good idea to include the field we are sorting on in the select statement for clarity. Order by can also be used to sort on multiple fields. It will sort by the first field specified, then sort by the next, etc. To specify multiple fields, we separate the field names with a comma. The second field we sort by can be thought of as a tiebreaker, when the first field is not decisive in telling the order. Here is an example. Let's say we wanted to find the best movie. In the first query, we are only sorting the films by the number of Oscar wins and getting a tie. We can break that tie by adding a second sorting field by seeing which film has the most wins and the highest IMDb score. We can also select a different order for each field we are sorting. For example, here we are sorting birth date in ascending order and name in descending order. Order by falls towards the end of the order of execution we already know, coming in just before limit. The from statement will execute first, then where, followed by select, order by, and finally, limit. Time to practice our new sorting skills. Time to practice our new sorting skill. Time to practice our new sorting skill. Execute first, then where, followed by select, order by, and finally,
order of execution. Okay, from where.
limit. Time to practice our new sorting skills.
Hello, Pierre. Hello, Pierre joined. Thank you. Hi, hello. Can I poke you? Okay, thank you so much. Okay, so sorting text. SQL provides us with the order by keyword to sort one or more fields from our data. It can do this multidirectionally and helps make results easy to interpret. So how does order by sort a column or a column of text values by default? So I think it's by default it is alphabetical. Okay, it's correct. Then sorting single fields. Now that we understand how order by works, we'll have to put it into practice. Then in this exercise, we'll have to work on sorting single fields only. This can be helpful to extract quick insights, such as the top grossing or top scoring film. Okay, the following exercises will help us gain further insights into the film database. So let's check on the films table, and again check on the columns of the films table. So for the instructions, select the name of each person in the people table. Okay, I thought it would be from the films table. So the instruction is from the people table. So select the name of the people and sort. So we have to select name. From people, order by. Order by name. So we don't have to specify the ascending or descending order since it's the default would be alphabetically. Then select the title and duration for every field from the longest duration to shortest. Longest duration to shortest, so it should be descending. Yay. So it says here that it's a superb sorting. Order by is another simple yet effective way to gain intelligence about your business and data. Now we know how to extract our best and worst performing assets with only a few lines of code. So now for the okay, sorting multiple fields. From the previous exercise, we only sort a single column Now we're going to have to sort multiple columns or fields. So order by can also be used to sort multiple fields. It will sort by the first field specified, then sort by the next, and so on. So for example, as an example, you may want to sort the people data by age and keep the names in alphabetical order. So now we have to try using order by to sort multiple columns. For the instructions, select the release year, duration, and title of films. Release year. Okay. And select the certification, release year. Certification, release year from films. Oh, okay, we have to include the title. From films ordered by certification. And second, ordered by certification followed by release year. Release year. Starting with the most recent year. So if we have to start with the most recent year, I think we have to put here descending order. Okay. It says here that the second column you order on only steps in when the first column has been ordered. Okay.
We've learned how to sort data. Next, we'll look at grouping our results. In the real world, we'll often need to summarize data for a particular group of results. For example, we might want to see the film data grouped by certification and make calculations on those groups, such as the average duration for each certification. SQL allows us to group with the group by clause. Here it is used in a query where we have grouped by certification. Group by is commonly used with aggregate functions to provide summary statistics, particularly when only grouping a single field, certification, and selecting multiple fields, certification and title. This is because the aggregate function will reduce the non-grouped field to one record only, which will need to correspond to one group. SQL will return an error if we try to select a field that is not in our group by clause. We'll need to correct this by adding an aggregate function around title. We can use group by on multiple fields, similar to order by. The order in which we write the fields affects how the data is grouped. The query here selects and groups certification and language while aggregating the title. The result shows that we have 5 films that have missing values for both certification and language, 2 films that are unrated and in Japanese, 2 films that are rated R and in Norwegian, and so on. We can combine group by with order by to group our results, make a calculation, and then order our results. For example, we can clean up one of our previous queries by sorting the results by the title count in descending order. Here is that query without order by, and this is the same query with ordering added. Order by is always written after group by, and notice that we can refer back to the alias within the query. That is because of the order of execution. It looks like movies rated R are the most common in our database. Group by fits into our order after from and before all other clauses. Our updated queries will begin with from, followed by grouping, selecting the data, and creating the alias, sorting the results, and limiting them to the desired number. In the following exercises, we'll examine our desired number. In the following exercises, creating the alias, sorting.
So should be for the group by order of execution. Select from group by, then followed by order by. Okay, then the limit.
The results and limiting them to the desired number. In the following exercises, we'll examine our film database to find out about release year, review, and budget patterns. Let's practice.
So find the release year and film count of each year. To do that, we have to, so let's first read instructions. So group by is a SQL keyword that allows us to group and summarize results with the additional use of aggregate functions. For example, films can be grouped by the certification and language before counting the film titles in each group. This allows us to see how many films had a particular certification and language grouping. In the following steps, we'll have to summarize other group of films to learn more about the films in our database. So for the instructions, select the release year and count of films released in each year alias as film count. Select release year and count of films. Let's see how will we count of films released in each year alias release year. Release count asterisk as film count from films group by. I think this is it. Okay, group by, and then select the release year and count of films released in each year alias as film count. Okay, submit the answer. Okay, that's correct. Then select the release year. My eyes is getting watery again. So then select the release year and average duration alias as average duration. Release year and average duration. To get the average duration, we have to use the aggregate function avg. From I think it's still the films. I think uh, with intermediate lessons, it's much easier than the then it's much easier than with the basic introduction. Okay. Then group by multiple fields. Group by becomes more powerful when used across multiple fields or combined with order by and limit. So perhaps we're interested in learning about budget changes throughout the years in individual countries. We'll have to use grouping in this exercise to look at the maximum budget. For each country in each year, there is data available. Again, so for the instructions, uh, for the instructions, okay. Select the release year, country, and the maximum budget, alias is max budget. So we have to select the release year, country, and the maximum budget. As max budget. Films, still the films table. Then for each year, so we have to group by this year and then the country. Well done. We can see how building on our SQL queries helps us gain more insights and detect trends in the data. So, such as how film budgets may change throughout the years. Yay. So, answering business questions. We're, I think we're getting there. I think I can finish this on time. Just on time. Maybe 9 o'clock in the evening here in the Philippines. Okay, so answering business questions. In the real world, every SQL query starts with a business question. Then it's up to you to decide how to write a query that answers the question. Then we have to try this out. Which release year had the most language diversity? What is meant by which release year had the most language diversity? Take your time to translate this question into code. We'll get you started, then it's up to you to test your queries in the console. Okay, most language diversity can be interpreted as count, distinct. No, over to you. What is meant by the diversity? Language diversity. Distinct language. Distinct language from no, from films. What's the question again? Which release year? That's okay. Release year. Sending na nga lang. Nineteen 16. So it's 1916. Hmm? Sending. Why should be sending? Where should I, where should I place the descending? From films, feature counting. Where should I place the descending? Group by, order by? Let me take a hint. You need to group by release year, but group by release year, but order by the language count. By, then order by. Can I do this? You need to group by release year, but order by the language count. However, you won't be ordering in the default order. So, language count diversity. So I think it's 2006. What is meant by diversity? I think diversity is language diversity. Okay. So we have to get the maximum. I thought I thought they're asking for the. Hi, hello, thank you. We get the diversity, so we get on the. Hello,
That was
hello, Miss
excellent
Sandra.
work. We've combined sorting and grouping. Next, we will combine filtering with grouping. In SQL, we can't filter aggregate functions with where clauses. For example, this query attempting to filter the title count is invalid. That means that if we want to filter based on the result of an aggregate function, we need another way. Groups have their own special filtering word, having. For example, this query shows only those years in which more than 10 films were released. The reason why groups have their own keyword for filtering comes down to the order of execution. We've written a query using many of the keywords we have covered here. This is the written order, starting with select from films, where the certification is G. PG or PG-13 group by certification, having the title count be greater than 500, order by title count, and limit to 3. In contrast, the order of execution is from, where, group by, having, select, order by, and limit. By reviewing this order, we can see where is executed before group by and before any aggregation occurs. This order is also why we cannot use the alias with having, but we can with order by. Where filters individual records, but we can with order by. We cannot use the alias with having, but we can with order by. Where filters individual records, while having filters grouped records. We'll walk through 2 business questions here to show how to translate them into the correct filter. The first question is, what films were released in the year 2000? This question does not indicate any sort of grouping. It asks to see only the titles from a specific year and can therefore be written as select title from
Thank you
films
so much.
where release year equals 2000. The second question is, in what years was the average film duration over 2 hours? Straight away, we can see this question has a few more layers. Let's break down the question and query into smaller, easier to understand steps. This question requires us to return information about years, so we select the release year from the films table. Next, it asks for the average film duration, which tells us we need to place average duration somewhere. Since we do not need to provide any additional information around the duration on its own, it is unlikely we need to perform the aggregation within the select clause. So we'll try the having clause instead. The last part of the question indicates we need to filter on the duration. Since we can't filter aggregates with where, this supports our theory about using having. Finally, we need to add a group by into our query since we have selected a column that has not been aggregated. Recall, the aggregate function will convert the duration values into one average value. Going back to the start of our question, we're interested in knowing the average duration per year. So we group it by release year. And there we have it. Let's improve our confidence with a final round of practice.
Final round. Wait. 70% having out. Okay. Love it. Thank you so much. Then filter with having. Our final keyword is having. It works similarly to were in that it is a filtering clause with the difference that having filtered group data. Filtering group data can be especially handy when working with a large data set. Okay, with a large data set. Then when working with thousands of or even millions of rows, having will allow you to filter for just the group of data you want, such as films over 2 hours in length. Then practice using having to find out which countries or country have the most varied film certifications. So get the country. Select country from the films table. Select the country and distinct count of certification. Okay. Select country and distinct count of certification as certification count. How do we get the certification count? Fields. Country from the fields table and get the distinct count of certification. Distinct count of certification. Okay. So once again, we have to get the use count distinct. Distinct certification. Certification count. Group by country. Finally. Group by country. Then filter the unique count of certifications to only results greater than 10. Punta din yung ilaw. Nahuhulog. Okay. Then 10 minutes. Filter results to countries with more than 10 different certifications. Select country from the films table and get the distinct certification alias as certification count. Count distinct certification. Okay. group the results by country, then filter the unique count of certifications to only results greater than 10. Having. Okay. I think the topic is on having. So we have to use the having clause instead of the were clause. Having certification count results greater than 10, greater than 10. Nalaglag siya. Thank you so much. And run the code. Ha ha ha, no output, your code generated an error. Why? Why? Certification count does not exist. Certification count. Why? Country count distinct certification as certification underscore count. Compares group by country. Having I have to place this in certification underscore count. Can I choose the aggregate function? Having count are the pwede gamitin. Distinct certification greater than 10. Okay. So that's what's all about. So this is the order of execution. Okay. With 12 different certifications. Okay. Having and sorting. And go down to how many more? Three topics. So having and sorting. Filtering and sorting go hand in hand and gives us the greater interpretability by ordering our results. Okay, so let's see this magic at work by writing a query showing what countries have the highest average film budgets. So having and sorting. For the instruction, select the country and average budget as average budget, rounded to two decimal, rounded to two decimal from films. Select country and budget as average budget. Diversity. One, two, three, one, two, three, one, two, three. Okay. So this is having average budget of greater than more than 1 billion. Order by descending order. Order by descending order of the aggregated budget. Order by wait, has to be average budget. Average budget. Okay. Select the country and average budget as average budget, rounded to two decimal. So we have to follow the instructions. Rounded to two decimal places. Then as average budget from films, group by country, filter the results to countries with average budget of more than 1 billion. Okay. Then order by, sort by descending order of the average budget. This is it. Run the code and submit the answer. Yay! South Korea and Hungary seem to have pricey films. Actually, these budgets are pretty standard for their local currency. Okay. All together now. And we're down to nearing the certification. And it's time to use much of what we've learned in one query. This is good preparation for using SQL in the real world, where we'll often be asked to write more complex queries, since some of the basic queries can be answered by playing around in spreadsheet applications. So in this exercise, we'll write a query that returns the average budget and gross earnings for films each year after 1990 if the average budget is greater than 60 million. This will be a big query, but we can handle it. So for the instructions, it's already 9 o'clock. For the instructions, select this release year for each film in the films table. Filter for records released after 1990 and group by release year. So select release year for each film in the films table. Where? List after, so greater than 1990. And group by release year. Okay. Modify the query to include average budget, alias as average budget, and average gross alias as average gross for the results we have so far. So really select modify the query to also list the average budget and average gross. Average gross. Select release year, average budget as average budget, average gross as average gross from films where release year is greater than 1990. Group by release year. Then modify the query once more so that only years with an average budget of greater than 60 million are included. So having and finally order the results from the highest average gross and limit to 1. Finally, order the results from highest to lowest. Order by highest to lowest average gross. Average gross. So ordered by average gross. Descending. I think this is it. Okay. And limit to 1. Limit to 1. Yay! You can get another. But breaking them down to individual clauses can make them easier to write. I think this is it.
Congratulations! We've made it to the end of the course. Let's take a look at everything we've learned. Our SQL vocabulary expanded by introducing the keywords count and limit in Chapter 1. We saw filtering techniques and is null and is not null in Chapter 2. We discussed round and aggregate functions in Chapter 3. Order by, descending, group by, and having in Chapter 4. We also covered comparison operators and arithmetic throughout. We now understand how to handle errors and missing values, and how to debug and write clean, readable code. Our new SQL vocabulary of keywords means we are proficient in selecting, querying, filtering, summarizing, sorting, and grouping data. That's quite a lot. Take a moment to celebrate this massive achievement. Where to from here? You're ready for our joining course if you want to continue learning. Alternatively, DataCamp offers several practice options throughout the project, practice, and competitions pages. Or head to Workspace and build a portfolio with your project. Best of luck, and remember, making mistakes is all part of learning.
Yay! Thank you so much. I'm finished. Next, statistics. I finished data visualization. I finished the introduction, the intermediate, the joining data. I think I have to do the statistics. Data manipulation. Functions for manipulating data, exploratory data analysis, data-driven division. Oh, so many. 1, 2, 3, 4, 5, 6, 7. Ang haba pa. Okay. So that's all for today. I finished this course, so I guess I'm hoping that talaga. Yes, I'm checking on the progress. I'm still 36%. So I still have six another 64% to complete. So this is just one third. I'm not even halfway for the certification. Anyway, it's okay. I have to stop. Thank you everyone. Thank you for joining me and thank you for I have to end the stream now. Thank